Recently, the GTX Great Train Express, a line of the Greater Seoul Metropolitan Area Express Railway, which connects Onjeong New Town in Paju, Gyeonggi Province, to Seoul Station, was opened. GTX A is 3 times faster than the subway, thanks to advanced train chassis technology and its deep underground placement at the 8th basement level. To achieve higher speeds, it must avoid contact with existing urban rail networks, power lines, and other infrastructure. Today, let's explore the world of high-speed bullet train technology. Hyperloop, overcoming ground, friction, and air resistance. If an airplane and a car were to race, which one would win? This competition has actually happened multiple times. In 2013, a Ferrari F1 machine, the best race car, competed against a Eurofighter jet, a combat aircraft. The Ferrari had a faster start, but the jet ultimately won the race. Experts explain that an aircraft, flying in the air where there's no surface friction, will always be faster than a car. The same principle applies to trains. At high altitudes, air density is only about 20% of what it is on the ground, meaning air resistance is significantly lower. This is why commercial airplanes can reach speeds of up to 900 km at an altitude of 10 km, while South Korea's fastest train, the KTX, has a maximum speed of only 348 km/h. To compete with airplanes in terms of speed, ground transportation must overcome both surface friction and air resistance. The dream solutions for these challenges are magnetic levitation, maglev trains, and Hyperloop technology. In early February of last year, a Hyperloop maglev train developed by a Chinese company recorded the world's fastest speeds. It is also known that Canada is developing a train that could carry 54 passengers and run at 1,000 km/h. How are such speeds possible? Firstly, maglev trains eliminate surface friction. This is achieved by using strong magnetic forces, repulsion between the same poles, and attraction between the different poles between the train's magnets and the coil circuits on the tracks, which acts as a magnet that changes the plus polarity. The repelling force between like poles lifts the train about 10 cm above the track, while the alternating polarity plus of the coil circuits generates an attractive force. That attractive force propels the train forward. However, air resistance remains a challenge. This is where Hyperloop technology comes in. Hyperloop involves constructing deep underground tubes, the roads where the trains run, and removing air from them, creating a near-vacuum environment where air resistance is nearly eliminated. Inside these tubes, a capsule-shaped train called a pod is installed and propelled using maglev technology, completing the Hyperloop setup. This setup mimics the conditions of an aircraft flying at a 10 km altitude, and in theory, it could allow speeds of up to Mach 3.